Okay, lesson 2.1, changing arithmetic and geometric sequences. So for this lesson, our skills and learning objectives include recognize, write, and find the nth term of an arithmetic sequences. Use arithmetic sequences to model real-world problems. Recognize, write, and find the nth terms of geometric sequences, and use geometric sequences to model real-world problems. All right, so in lesson 1A, the change in arithmetic and geometric sequences. It says when you first think of a sequence of events, you likely would consider what happened first, second, and so on. In mathematics, the word sequence is also used in the same way. Some list of numbers, it has a first element, a second element, a third element, and so on. One famous example, known as the Fibonacci sequence, is found throughout nature, which is 1, 1, 2, 3, 5, 8, 13, 21, 34, etc. Can you discover the rule for the nth term? And so what we notice here is that it starts out with a 1, and then it has another 1, and then it's a 2. And after the 2 is a 3, and after 3 is a 5. And so if you notice, if you're looking for a pattern, it's just the two previous numbers added together. So like if I take 3 plus 5, it's going to give me my next number, which is 8. Or if I take 5 plus 8, it'll give me the next number is 13. So my next number here, if I have 21 plus 34, the next number would be 55. All right, so definition of a sequence. It says an infinite sequence is a function whose domain is a set of positive integers. The function values are the terms of the sequence. So we have a sub 1, a sub 2, a sub 3, a sub 4, which is our first term, our second term, our third term, our fourth term. And it keeps going till we get to our nth term. And then because it's infinite, it's going to keep going even after that. So that's why it's comma, dot, dot, dot. All right, but it says if the domain of the function consists of the first n positive integers only, then that sequence is finite sequence. So if it only contains a certain number, doesn't keep going, it's finite. If it keeps going, it's infinite. So a little bit of vocab here. The nth term is just your general term. The letter K is sometimes used instead of n, so I might say the kth term. A finite sequence has a certain number of terms. Remember, infinite keeps going. And the term of a sequence is just each number in a sequence. All right, so example 1 says a sequence has an explicit formula, a sub n equals 12n plus 3, find a sub 12. So we know that a sub n is equal to 12n plus 3, and we're looking for a sub 12. So notice that the n has now changed to a 12. So over here where we have an n, we're actually going to plug in a 12. And so 12 times 12 is 144, plus 3 is 147. And then example 2 wants us to find the first 4 terms of each sequence. So we're going to be looking for our first term. So we're just going to, n is now 1, so we got 3 times 1 minus 4. Looking for the second term, n is now 2. 3 times 2 minus 4. Third term, n is now 3. 3 times 3 minus 4. And then our fourth term, where n is now 4, so 3 times 4 minus 4. And there's our first 4 term numbers of that sequence. Same thing for B. So we're going to plug in 1 for our a sub 1 for our first term. So 5 plus negative 1 to the first. Remember, if a negative number is raised an odd exponent, it's going to stay, if our negative number is raised an odd exponent, it stays negative. If it's raised an even exponent, it becomes positive. So, and then 1 to the first is just 1. So we got 5 plus negative 1, which is 4. Second term, we're going to plug in a 2. This time we get 5 plus 1, because it turned positive, which is 6. Third, so plug in a 3. So we get 5 plus negative 1 cubed is negative 1. So we got 4. And then for our fourth term, we get 5 plus negative 1 to the fourth, which is 5 plus negative 1 to the fourth is positive 1. So 5 plus 1 is 6. And so there's my first 4 term numbers. All right, example 3. So the sequence is given by a sub n equals 4 plus n minus 1 times 5. Find the first 3 terms. So a sub 1, So 4 plus 1 minus 1 times 5. 4 plus 0 times 5, which is 4. A sub 2, so plug in now 2 for n. So we get 4 plus 1 times 5, which is 9. And then for the third term number, we're going to plug in a 3 for n. So it gets 4 plus 2 times 5, which is 14. And then B says just find the 11th term. So we're just looking for A sub 11. So we're just going to plug in 11 for n. So we get 4 plus 10 times 5, which is just 54. All right, arithmetic sequences. And arithmetic sequences have the same difference between terms. So you can add, going from one number to the next, it should have a common difference there, okay? So it's going to be represented by the letter D, and we can find that by taking A sub 2 minus A sub 1, A sub 3 minus A sub 2. So you're just taking one term minus the term in front of it to find that common difference. But remember, it's got to be in common, so it has to be between each of them. Now it says here that it's the same differences between terms we're going to add. It could be subtract, because remember, subtracting is just adding a negative number. All right, then we have two different forms here. We have the explicit form, which is A sub n equals A sub k plus d times n minus k for all n greater than or equal to 1, where A sub k is our kth term. Or the general form, which is A sub n is equal to that common difference d times n plus A sub 0. Now, we don't know A sub 0. It's typically not given to us because we always start with our first term, so we start with A sub 1. But we can find A sub 0 by taking that first term and subtracting that common difference. All right, so example 4 says, is this sequence an arithmetic sequence? And if so, write the general rule. Well, how would I get from 1 to 5, 5 to 9, 9 to 13, 13 to 17? Each time we're adding 4. So our common difference there is 4. That's really big. I'm going to write a little smaller there. All right, now to find A sub 0, it told us it's A sub 1 minus that common difference. So it's 1 minus 4, which would be negative 3. So my general rule is that A sub n equals dn plus A sub 0. So A sub n is equal to 4n, and then A sub 0 is a negative 3. Then example 5 says to find the 46th term of that sequence. Well, if I can do like I did on the previous one and come up with a general rule, then all I have to do is plug in 46 for n, and we'll find our 46th term. So let's do the same thing we did in the one above. So we're going to find our rule. And so I can see here that each time we're adding 3. So our common difference is 3. A sub 0 is our first term minus the common difference. So we find our first term is negative, or 0 term, is negative 1. And so we know the general rule is A sub n equals dn, so 3n, plus A sub 0, so minus 1. So our rule is going to be 3n minus 1. And then we're looking for the 46th term. So we're just going to plug in n as 46. Gives me 138 minus 1. Which tells me my 46th term would be 137. Example 6 is find the 9th term of the arithmetic sequence whose first term is 8 and whose common difference is negative 5. So they tell me my first term is 8. My difference is negative 5. So I can find that 0 term, because remember, it's the first term minus the difference. Now be careful, because that's minus a negative, which means my first term is 13. I'm sorry, my 0 term is 13. So I know my equation is A sub n equals dn, so negative 5n, plus A sub 0, so plus 13. And then we're looking for the 9th term, so we're looking for A sub 9. So negative 5 times 9 plus 13. Negative 45 plus 13. which is negative 32. Example 7 says the numbers in the sequence below follow a general pattern. Can you write the general rule? So we notice here each time these are increasing by 0.25, or if you're unsure, remember, take the second term minus the first term, which should be the same as the third term minus the second term. Either way, we get 0.25 as our common difference. So my zero term is going to be the first term minus that common difference, which is 0.75. And so my general rule is A sub n equals dn, so 0.25 n, plus A sub 0, so plus 0.75. And on B, see my common difference is negative 1 minus 4, or we could say it's negative 16 minus negative 11. Either way, we get negative 5. We're decreasing by 5 each time, if you want to look at it that way. A sub 0 is our first term minus our common difference, so we get 9. So my rule is A sub n equals dn, so negative 5n, plus A sub 0, so plus 9. All right, so remember, if my numbers are getting smaller as we go to the right, then that A sub 0 should be a bigger number. So just remember that, so in case you get mixed up with that minus and a negative, you know that since it's in decreasing order above, that the number we're looking for A sub 0 has to be bigger. All right, example 8. It says the number of seats in the number of seats in the first 16 rows of an arena form an arithmetic sequence. If there are 20 seats in row 1, 23 seats in row 2, how many seats are in row 16? And so we can see here that in row 1 we have 20, and in row 2 we have 23, and it told us it's arithmetic, so it's got that common difference. So then we know it'd be 26, 29, and so forth. All right, so we can see that our common difference then is 3. We're increasing by 3. Our zero term is our first term minus the common difference, so it's 17. And so we know our general rule, A sub n, is equal to dn, so 3n plus A sub 0, so plus 17. And then we're looking, wrong number. We're looking for row 16 there. So we have 3 times 16 plus 17. So there are 65 seats in row 16.